Imagine you open your eyes in the absolute dark, and your heart is pounding heavily in your chest. You just woke up from a completely absurd, entirely fabricated alternate reality where the normal laws of physics simply did not apply. In this bizarre mental landscape, you were perhaps running away from something terrifying, but your legs felt unbelievably heavy, or you were standing in a place you have not seen since childhood. Have you ever actually stopped to ask yourself why your biological body forces you to experience these vivid, intense hallucinations for several hours every single night? Why does your perfectly rational mind construct completely immersive imaginary worlds only to quietly and efficiently delete almost all of them from your memory 10 minutes after you wake up? What exactly is the evolutionary point of this nightly theater? To truly understand why we dream, we must dive deep into the terrifying reality of prehistoric nights. The explosive development of the infant brain, the hidden consciousness of the animal kingdom, the ancient healing rituals of early civilizations, and the extraordinary chemical cascade that happens in the final moments of a human life. Before we answer why you dream, we need to look at how unbelievably dangerous it is to dream in the first place. Sleep is, biologically speaking, the single most dangerous thing a human being does on a regular basis. For roughly a third of your entire life, your muscles go slack. Your awareness of the outside world drops to almost nothing, and you become functionally a large, motionless, completely defenseless pile of calories lying on the ground. If you were a predator scanning the landscape for an easy meal, a sleeping human is about as close to a free lunch as nature offers. Let us travel back hundreds of thousands of years into a brutal prehistoric landscape. We sometimes like to imagine ancient humans as tough, rugged warriors casually wrestling lions. But that is not the reality. Early humans were, biologically speaking, a soft, slow, and essentially naked prey animal in a world full of creatures built specifically to destroy things like them. There were prehistoric hyenas the size of a modern lion, with jaws strong enough to crush the femur of a full-grown elephant. There were multiple species of saber-toothed cats with canine teeth up to 28 centimeters long. There were cave bears that stood 12 feet tall and weighed 1,000 kilograms. In this landscape of absolute terror, the specific phase of sleep where you experience your most vivid dreams is infinitely more dangerous than regular sleep. When you enter rapid eye movement sleep, the stage most strongly associated with vivid dreaming, your body experiences a temporary, near-total loss of voluntary muscle control. Researchers call this deeply vulnerable state atonia, and it exists specifically to prevent a sleeping person from physically acting out their dreams. You are, for those specific minutes, almost completely incapable of mounting any kind of physical defense whatsoever, regardless of what might be approaching you in the dark. Ask yourself this profound question. If evolution is a ruthless, unforgiving filter that constantly eliminates weakness, why would it mandate a period of total physical paralysis in a world filled with massive nocturnal predators? Some researchers have speculated that the deeply unsettling, almost universal cultural phenomenon of sleep paralysis, a frightening state where a person briefly wakes while atonia is still partially active, leaving them conscious but unable to move, connects directly to ancient, deeply ingrained anxiety, specifically tied to this exact moment of maximum physical vulnerability. The fact that this extreme vulnerability survived the brutal filter of natural selection means that whatever is happening in your brain while you dream is absolutely critical to your survival. So how did our ancestors survive this daily biological paralysis? They survived because they absolutely never slept alone. A solitary sleeping human represents close to the worst possible combination of circumstances imaginable from a predator perspective: completely unaware, completely immobile, and completely alone with no one nearby to raise an alarm. Sleeping in a group fundamentally changes this entire risk calculation because human sleep cycles through multiple distinct stages. Individuals in a group are naturally at slightly different points in their own personal sleep cycle at any given moment. This means a group sleeping together effectively maintains a rotating, overlapping baseline of partial alertness throughout the night. Group sleeping arrangements were frequently organized directly around a central fire, and maintaining that fire through the night required occasional attention. The fire provided a boundary that almost nothing was willing to cross. The smoke drove off insects, and the heat allowed survival in freezing conditions. During the night, people did not sleep in one unbroken 8-hour block. They practiced segmented sleep, involving a first sleep period, a period of wakefulness in the middle of the night, and a second sleep period before morning. During that middle-of-the-night wakefulness, people engaged in quiet social interaction, tended the fire, and provided overlapping vigilance for the group members who were deeply submerged in their paralyzed dreaming states. Your ability to lie in a dark, quiet room today and dream in perfect safety was bought and paid for by hundreds of thousands of years of your ancestors keeping watch over each other by the light of a flickering fire. Now we must ask what exactly the dream is accomplishing to justify this massive risk. To find the answer, we need to look at the humans, who sleep more than anyone else on the planet. Newborn infants sleep 16 to 18 hours a day, and their sleep architecture is radically different from adult sleep. They spend far more of their sleep time in active rapid eye movement states than adults do. For decades, researchers incorrectly assumed this was just a biological quirk of development with no particular significance. It turns out that assumption was completely backwards. Some researchers now strongly believe that the enormous amounts of active sleep in infancy serve a specific and profound developmental function. They are not storing discrete memories of the day because the hippocampus, the brain region responsible for indexing memory, is dramatically functionally incomplete in the first years of life. Instead, during those endless hours of dreaming, the infant brain is consolidating the foundational patterns that underlie all future learning. They are learning how faces work, how voices carry emotional meaning, how physical objects behave in three-dimensional space, and how social interaction flows. The infant sleeping for 18 hours is actively building the operating system that everything else in their life will eventually run on. Rapid neurogenesis in the infant brain adds new neurons so fast that it constantly disrupts memory consolidation, acting like a chaotic young library, adding hundreds of new shelves every single day. You do not remember learning to see the world or learning to read human faces, because all of that incredibly complex processing was learned and solidified in the years you cannot explicitly remember, precisely because it got filed in a different, deeper format during those early years of intense dreaming. Your dreams when you were a baby literally compiled the reality you currently live in. And we are not alone in this nightly ritual. The circle of creatures who experience this virtual reality is vastly wider than humans. If you share your home with a dog, you have likely watched its small legs twitching, as if it is running fast, chasing something completely invisible in its sleep. That twitching is undeniably cute, but it is scientifically significant, because it is undeniable evidence that animals dream. Dreaming is an ancient biological mechanism shared across countless species. If an animal dreams, it means there is someone in there looking out. It means they experience the world from a first-person perspective and possess an inner life that continues to process emotional and sensory information even when their eyes are tightly closed. When your dog dreams, its brain is likely running through the experiences of its day, organizing memories and processing the emotional values of the world it navigates. Evolution preserved this dreaming mechanism across millions of years of mammalian development, which strongly suggests that the dream state is a highly conserved evolutionary tool. Dreams are the ancient invisible threads that tie human consciousness to the consciousness of the wild creatures we share this planet with. Ancient humans did not have access to modern neuroscience to understand what was happening in their brains, but they fully recognized the profound psychological power of the dream state. They understood intuitively that dreams were a bridge to a different kind of consciousness. In ancient Egypt, medical and spiritual frameworks were deeply intertwined. The Egyptians treated mental and emotional disorders as medical conditions rather than purely spiritual ones. There was an ancient Egyptian temple complex dedicated to the healing god Imhotep, where mentally distressed individuals would come sleep in the sacred precinct and receive dream interpretations that were meant to guide their healing. This practice is known as incubation therapy. Patients were prescribed therapeutic dreams in a peaceful garden setting. The ancient physicians recognized that the mind required a safe environment to process its trauma. Through the symbolic language of dreams, they did not dismiss the nighttime hallucinations as random noise. They harnessed them as a tool for psychological integration and healing. But perhaps the most extraordinary purpose of the dreaming brain is revealed only at the very end of a human life. What role does the dreaming mind play in the final 60 minutes of human existence? For most of the history of medicine, death was understood as a relatively simple off switch. Where the heart stops blood flow, ceases, the brain runs out of oxygen, and everything goes dark. Modern research has begun to suggest that this picture is radically incomplete. In the seconds immediately following cardiac arrest, the brain does not simply go quiet. In studies monitoring the brains of dying subjects, researchers discovered that the brain can explode with highly organized electrical activity. There is a rapid surge of high-frequency gamma oscillations, the exact same brain wave pattern associated with heightened consciousness, focused attention, memory retrieval, and incredibly vivid dreaming. The dying brain, starved of oxygen, does not simply power down. It briefly and paradoxically goes into absolute overdrive. While this electrical storm is happening, the body is also releasing a massive cascade of powerful neurochemicals. Endorphins, the natural opioids of the brain, are produced in large quantities to buffer pain and create profound feelings of calm and euphoria. Serotonin is released in highly elevated amounts, regulating mood and potentially altering time perception. Some researchers propose the rapid eye movement intrusion hypothesis, which suggests that the brain stem in an absolute biological emergency may trigger something strongly resembling a dream state in a brain that is otherwise becoming unconscious. When you combine the gamma wave surge, the flood of serotonin and endorphins, and the sudden intrusion of rapid eye movement sleep architecture, you get a biological recipe for the most intense immersive dream imaginable. This extraordinary internal state might be the neurological foundation of what near-death experience survivors consistently describe across completely different cultures. They describe a feeling of profound vividness, a sudden comprehensive life review, the sense of memories flooding back with extraordinary clarity, a tunnel of light, and an overwhelming sense of profound peace. The dying brain, with absolutely nothing left to lose, may briefly produce one of the most intense conscious experiences in a human lifetime. It is deeply moving to consider that the very same biological machinery that built your understanding of reality when you were an infant might activate one last time to construct a final, beautiful, coherent narrative out of your fading sensory signals. So let us return to the original question. Why exactly do we dream? We do not dream because our brains are glitching or randomly firing useless static into the void. We dream because we are ancient, incredibly complex creatures navigating an unpredictable reality. We dream because the extreme physical vulnerability of being paralyzed in the dark was an evolutionary price our ancestors were willing to pay for the massive cognitive benefits of sleep. We dream because when we were infants, our rapidly expanding brains desperately needed a safe virtual space to compile the raw, chaotic data of the world into the stable operating system of our minds. We dream because we share a deep, unbroken evolutionary heritage with the animal kingdom, a heritage that uses the quiet of the night to process the survival lessons of the day. We dream because ancient cultures recognized the profound healing power of our sleeping minds, utilizing the silence of the night to repair the traumas of the day. And perhaps most profoundly, we possess this extraordinary dreaming architecture so that when the final moment comes, our minds know exactly how to guide us gently into the dark, with one last profound and peaceful vision. The next time you wake up from a strange, confusing, or emotionally intense dream, do not simply brush it off and reach for your phone. Take a moment to appreciate the staggering biological miracle that just happened inside your skull. Every time you close your eyes and slip into a dream, you are not losing your grip on reality. You are actively participating in one of the oldest, most essential, and most profoundly beautiful biological rituals on planet Earth. You are running the ancient software that made you human.